thought I'd better explain to the techie guys in the mecha how that fix actually works. I don't know how well this will come out, but having your computer linked up to your 42-inch TV in the living room is quite handy. Anyways, this is the Mega Reset and Watchdog circuit here. It's on sheet 4 or 5 of the schematics if you've got them downloaded for yourself. Looks pretty daunting, doesn't it? A lot of different elements to it. Definitely catches a lot of people out, but there's actually a lot of it that you can ignore. I'll give you a gist to how it works. Start off this comparator here, U46. As one side set to reference voltage of about 2 volts, and there's a aerial line that comes from there. Basically, if you get a pulse through there, you trigger that, and you trigger the reset timer here. Reset timer here, U27, one half of it, is also self-triggering at power up. 5 volts comes in, charges that capacitor there. Once that's charged up, timer times out, fires the output. Output goes up to that inverter there, U6, which is your reset out. Now, you see that diode down here, diode D24, right there. We'll come back to that in a second. Next part of your reset here, your reset circuit, is U28. It's another comparator. You see this line here, V-Sense. This line comes from your power supply. It's basically off your 12 volt rail. Goes down there through to that comparator. Zoom in on it. One side of the comparator is set to about 2.5 volts reference voltage, and the other side is set to detect whether you're above or below that. Ooh. And my camera's lost track of what it's doing, so in a second. My balance is going kind of gaga there. Alright, not to worry. We get the gist of what's going on. I'll just look over here. Ah, there's back. Camera does that from time to time. Hope that doesn't show up in the video. But anyway, that V-Sense line comes down there. If your V-Sense is under 2.5 or slightly over compared to this will drop low, and it triggers your halt light in your CPU. CPU halt is active low. That in turn stops the Watchdog counter, which comes off your PAL chip, into this line here, which allows this side of the U27, the other half of the 556, to be triggered through that transistor, times out, fires the Watchdog. In addition to that, as well as triggering that transistor, send a signal through D24. It feeds back, and feeds back, and feeds back, and feeds back, and goes straight to reset out. So if that's dropped low, if your Watchdog lines drop low, Watchdog out, you get low at reset out. There's a couple of other lines here as well. There's this comp 1 line. I believe what that's for is to keep pulsing this over and over so it never times out, so the reset never re-triggers. I've measured it with a logic probe on the actual board, and it seems to be pulsing away. And that's just about it. Now, back to D24. Right here. See how we're connected? D24 is connected to this transistor, and then it comes back and connects to res out there. I'm putting a 5 volt supply to the anode of D24. Right there. Now that's got a double benefit. One, it sends a 5 volt route, it ties this whole rail with 5 volts, which means that this point here is always high. The reset line will always be high, unless you actually take the wire link off and allow the reset counter to pulse, or you put it to ground and force it manually. In addition to that, you're getting a double benefit because you're also applying a constant 5 volt signal to here. Goes through that. 0.6 at the base Q4, Q4 being an NPN transistor, you put 0.6 there, you turn the thing off. Which means that this timer is never going to time out. That Watchdog outline is always going to be high. That Watchdog outline always being high, that always being locked off, and that timer there never been able to affect this, which means that the timer can never be re-triggered. It means you've got total control of the Watchdog. In other words, putting a 5 volt line there effectively turns the whole Watchdog off. It doesn't turn it off, but it inhibits it from operating. And you might think, well, anytime this pulse is low anyway, you'll still get low here. Well, you won't. It's basically the law of electronics. Electricity and current always follows the path of least resistance. There's no pull-up resistor or solid hole there, so that's always going to be high. It's a really easy little mod. It'd probably be pretty easy to put a little permanent switch somewhere on the M1 board, tying from that point through a switch to 5 volts and ground. But it's really handy that I figured out how to do it, because it means now that I don't have to sit and try and figure out what a chip's doing or not doing by either using a logic pulse or staring at schematics, because I'm only seeing a pulse every second or so as the reset briefly goes off and then locks everything back up. It means now I can actually let the board run, and then I can work out what's working and what's not working with my logic probe or oscilloscope, as that matter. But me being me, I'm not keeping the information to myself. I like to pass on what I've learned, and I know we've all got, a few of us have got plenty of media boards to get through, so hopefully this will speed the process up a bit. Alright, bye for now.